In this video, we will learn how to find the transfer function of a low-pass filter circuit using nodal analysis. First, let's convert all components into their Laplace or S-domain equivalents. Resistors remain unchanged in the Laplace domain. Inductors becomes L times S, and capacitors become 1 over Cs. In our circuit, a 1 ohm resistor stays 1 ohm, the 2 Henry inductor becomes 2S, the 1 over 4 farad capacitor becomes 4 over S, and the 1 over 8 farad capacitor becomes 8 over S. Next, we will apply Kirchhoff's current law to write nodal equations. At node A, 3 currents leaving the node are through the 1 ohm resistor from the source, through the 4 over S capacitor, and through the 2S inductor toward the output. This gives us the following nodal equation. Let's call this equation 1. At the output node, we also have 3 currents leaving from node A through the inductor, through the 8 over S capacitor to the ground, and through the 1 ohm resistor to the ground. So after applying KCL at the output node, we obtain following nodal equation. Let's call this equation 2. By the way, if you like what you are watching, please hit the like button and also subscribe to the channel. Now back to the video. From here, we substitute equation 2 back into the first equation. Now we multiply and simplify this expression. And after combining like terms, we get finally we isolate the transfer function. To simplify, we multiply numerator and denominator by 16. Thanks for following along. You can find more quiz and solve problems on this topic in the post section of my channel.